Komodo dragons, Varanus komodoensis, the largest living lizards, are apex predators native to a few Indonesian islands. One of the most fascinating and deadly aspects of their hunting strategy is the role their saliva plays in subduing prey. The idea that their bites are lethal due to a cocktail of bacteria in their saliva has been a topic of interest for researchers, though recent studies have nuanced this understanding. Below, I'll explain in detail how their saliva contributes to deadly infections, the types of bacteria involved, the mechanisms of infection, and the evolving scientific perspective on their bite. 1. The role of saliva in Komodo dragon bite. Komodo dragons are carnivorous predators that rely on a combination of physical strength, sharp teeth, and their unique oral environment to take down prey, which can include deer, wild boar, water buffalo, and even smaller Komodo dragons. Their saliva is a critical component of their predatory arsenal, as it harbors a complex microbial ecosystem that can cause severe infections in bitten prey. Bite mechanics. Komodo dragons have serrated, shark-like teeth designed to tear flesh, creating deep, open wounds. These wounds provide an entry point for bacteria present in the dragon's saliva. Saliva as a bacterial reservoir. The oral cavity of a Komodo dragon is a moist, nutrient-rich environment that supports a diverse microbial community. When the dragon bites, saliva is transferred into the wound, introducing bacteria that can proliferate in the prey's tissues, infection as a hunting strategy. Unlike venomous animals that rely on toxins for rapid kills, Komodo dragons often use a bite-and-wait strategy. After biting, they may track weakened prey over hours or days as infection and blood loss take their toll, making the prey easier to overpower. 2. Bacterial diversity in Komodo dragon saliva. Research has identified over 50 distinct strains of bacteria in the saliva of Komodo dragons, many of which are pathogenic, disease-causing, to mammals. These bacteria contribute to the lethality of their bites by triggering severe infections, such as sepsis, in bitten animals. Key studies: a 2009 study by Brian Fry and colleagues used molecular techniques to analyze the oral flora of Komodo dragons. They identified a wide range of bacteria, many of which are associated with wound infections in mammals. Other studies, including one from 2013 by the University of Queensland, confirmed the presence of highly pathogenic strains. Common bacterial strains. Some of the most frequently identified bacteria in Komodo dragon saliva include Pastorella multocida, a highly virulent bacterium known for causing rapid, severe infections in mammals, often leading to sepsis. Staphylococcus sp. includes strains like Staphylococcus aureus, which can cause skin infections, abscesses, and systemic infections. Streptococcus spp. These bacteria can contribute to tissue necrosis and systemic infections. Escherichia coli, a common gut bacterium that, when introduced into wounds, can cause severe infections. Pseudomonas spp. Known for causing chronic infections, particularly in immunocompromised hosts. Clostridium spp. Anaerobic bacteria that can lead to gangrene or other tissue-destroying infections. Aeromonas spp. Associated with water-related infections and known for causing rapid tissue damage. Diversity and variation. The exact bacterial composition varies between individual dragons and their environments. For example, dragons feeding on carrion may harbor different strains than those hunting live prey, as their oral microbiome is influenced by diet and habitat. 3. Mechanism of infection. The lethality of a Komodo dragon's bite is not due to a single factor, but rather a synergistic effect of physical damage, bacterial inoculation, and the prey's physiological response. Here's how the process unfolds. Wound creation. The dragon's serrated teeth create deep, jagged wounds that are difficult for the prey's body to close or heal naturally. These wounds provide an ideal environment for bacterial growth, as they are rich in blood and tissue fluids. Bacterial inoculation. During the bite, saliva laden with bacteria is deposited into the wound. The bacteria begin to multiply rapidly in the warm, nutrient-rich environment of the prey's tissues. Infection progression. Local infection in bacteria like Pastorella, Multocida, and Staphylococcus spp cause localized inflammation, swelling, and tissue damage. This can lead to abscesses or cellulitis, a bacterial skin infection. Systemic infection. If untreated, the infection can spread through the bloodstream, causing sepsis, a life-threatening condition where the body's immune response causes widespread inflammation and organ failure. Tissue necrosis. Anaerobic bacteria like Clostridium sp thrive in low-oxygen environments, e.g., deep wounds, and can cause gangrene, where tissue dies due to lack of blood flow. Weakening of prey. The combination of blood loss from the initial bite, pain, and systemic infection weakens the prey, making it unable to flee or fight effectively. This allows the Komodo dragon to track and finish off the animal. 4. The venom debate. For decades, the prevailing theory was that the Komodo dragon's bite was lethal solely due to bacterial infection. However, research in the early 2000s by Brian Fry and others revealed that Komodo dragons also possess venom glands, challenging the bacteria-only hypothesis. Venom glands. Komodo dragons have complex venom glands in their lower jaw that secrete a mix of proteins and peptides with anticoagulant and hypotensive, blood pressure-lowering effects. These compounds exacerbate blood loss and shock in prey, complementing the bacterial infection. Synergistic effect. The venom likely enhances the lethality of the bite by weakening the prey's ability to fight infection, e.g., by impairing blood clotting and immune responses, while bacteria proliferate in the wound. Current understanding. While venom plays a significant role, the bacterial load in the saliva remains a critical factor in the dragon's ability to kill large prey. The venom may act quickly to debilitate, while the bacteria ensure a slower, inevitable decline if the prey survives the initial attack. 5. Ecological and evolutionary context. The presence of pathogenic bacteria in Komodo dragon saliva is likely an evolutionary adaptation that enhances their predatory success. Diet and environment. Komodo dragons are opportunistic feeders, consuming both live prey and carrion. Their oral microbiome is shaped by their diet, as decomposing flesh introduces a variety of bacteria into their mouths. This may explain the high prevalence of pathogenic strains. Immune adaptations. Interestingly, Komodo dragons appear to be resistant to their own oral bacteria. Their immune systems likely produce antimicrobial peptides or other defenses to prevent self-infection, though this area is still under study. Comparison to other animals. Other carnivores, like crocodiles and monitor lizards, also harbor bacteria in their saliva. But the Komodo dragon's combination of venom, bacteria, and physical prowess makes its bite uniquely deadly. 6. Implications for humans. While Komodo dragon attacks on humans are rare, they can be fatal due to the same mechanisms that make their bites deadly to prey. Human cases. Bites to humans often result in severe infections requiring immediate medical intervention, including antibiotics and wound care. Without treatment, infections can progress to sepsis or gangrene. Medical insights. Studying Komodo dragon saliva has provided insights into antibiotic resistance and the development of new antimicrobial treatments, as some of the bacteria are highly resistant to common antibiotics.